Today, we're going to explore the fascinating world of how robots can work together in complex, high-stakes environments. We're not just talking about simple cooperation, but scenarios like surgical robots collaborating on a single operation or fleets of robots maneuvering through a crowded warehouse. This field is known as multi-robot motion planning, and it represents one of the most exciting frontiers in robotics. Coordinating multiple robots, especially in scenarios where precision and timing are everything, presents a unique set of challenges and opportunities. As detailed in the research paper we're discussing today, traditional methods of multi-robot coordination have often relied on either coupled or decoupled planning approaches. In coupled planning, the system tries to coordinate every single move for all robots simultaneously, essentially micromanaging the entire process. This method, however, becomes nearly impossible to scale as the number of robots grows, leading to a computational bottleneck. In contrast, decoupled planning lets each robot map its route independently, which is computationally easier but can lead to conflicts, reducing efficiency and increasing the likelihood of collisions. To address these limitations, the paper introduces an innovative approach called Experience-Based Adaptive Robot Coordination, or EARC. This approach leverages precomputed solutions to smaller, manageable subproblems, creating a kind of library of past coordination strategies. Instead of attempting to solve every coordination problem from scratch, EARC searches through this database to find a close match, which it then adapts to the current situation. It's almost like following a recipe from a cookbook for robot coordination, efficient and reliable, with the ability to learn from past solutions. What makes EARC particularly exciting is that it's not static. Each time a new challenge is encountered and solved, that solution is added to the EARC library, effectively making the system smarter and more adaptive over time. This learning capability could revolutionize fields where high-stakes, precise robot coordination is crucial. For example, in medical settings, EARC could enable multiple robotic arms to work together seamlessly during surgery, performing complex procedures with unparalleled precision and coordination. Imagine the possibilities for minimally invasive surgeries and shortened recovery times. Beyond medicine, the potential applications for EARC are vast. In manufacturing, for instance, it could orchestrate a team of robots on an assembly line, ensuring that each robot operates in harmony to maximize productivity. Logistics and warehouse management are other areas where EARC could have a transformative impact. Picture a busy warehouse where robots retrieve items, sort packages, and load trucks, all synchronized and guided by EARC to avoid bottlenecks and delays. This could dramatically improve efficiency and speed up supply chains. The research demonstrates EARC's advantages over both coupled and decoupled planning methods, especially in terms of efficiency and scalability. By breaking down complex tasks into smaller, manageable parts, EARC reduces computational demands, allowing it to handle larger numbers of robots. Its conflict resolution mechanisms ensure that robots avoid potential collisions by constantly monitoring their paths, making EARC much like an air traffic controller for robotic systems, maintaining smooth and safe operations. In terms of adaptability, EARC supports both concurrent and sequential tasks, making it a highly flexible solution. Robots can perform actions simultaneously or in a defined order, depending on what the situation requires. This versatility could make EARC invaluable in dynamic environments like emergency response or disaster recovery, where conditions are unpredictable and every second counts. With its blend of efficiency, scalability, and adaptability, EARC could represent a new standard in robotic coordination across numerous industries. As we look to the future, the impact of EARC and similar technologies will be profound. It's not just about robots performing tasks, but about creating genuine partnerships between humans and robots, where each plays to their strengths. In the coming years, we'll see EARC and other robotic systems not just as tools, but as collaborative partners, reshaping industries from healthcare to manufacturing and beyond. Thanks for watching. Don't forget to like and subscribe to our channel.
See you next time.